Welcome back. We'll continue from where we left off last time, but before that a brief recapitulation of what we did in the last class. In the last class we started with the introduction of the salient features of various derivatives, forwards, futures, options and swaps. Forwards are essentially contracts which are entered into as of today. The negotiation is as of today, the price and other terms of delivery are fixed as of today, are agreed as of today, and the actual settlement of the contract, that is the payment of the price and the receipt of the asset, is at a future date. In the case of futures, it is very similar to forwards, except for the fact that futures are traded on recognized exchanges, and because they are to be traded on recognized exchanges, it mandates that they have to be standardized, and in addition the risk element has to be eliminated, the chances of default has to be eliminated, so that the trading is uninhibited. Then we talked about options. Options are slightly different from forwards and futures in the sense that one of the parties to the option contract has a right, the discretion to exercise the option or not to exercise the option, that is to let the option lapse. The other party to the contract, however, is obliged, is mandated to honor his leg of the commitment, he has no discretion. And then swaps are contracts which involve an exchange of cash flows over a future period of time in installments as per a pre-agreed formula, which is incorporated, which is embedded in the swap contract. So, these are the four fundamental types of derivatives that are commonly available in the market. There are many numerous variants of these derivatives. There are futures options and swaptions and variants of those, or even options are of multiple varieties. Then we went on to pricing of forward contracts. We talked about pricing of forward contracts. Here we invoke the concept of no arbitrage. I would like to come back to this principle in a few minutes, but before coming back to the issue of no arbitrage, I also discuss the relevance or the appropriateness of the risk free rate as the measure of time value of money in the context of pricing of forward contracts. Now, the issue there was that where the time value of money or where the interest rate comes into the picture. It comes into the picture because we are borrowing a certain amount of money at t equal to 0, and we buy the underlying asset at t equal to 0 in the spot market, keep it with us and thereafter deliver it against the short forward position. Now, at this point we are assuming that the forwards are default free. In other words, the cash proceeds that we are going to receive under the forward contract are certain. There is no risk element involved in that. So, because we are assuming that the forward contracts will be honored and we shall get the cash, it is natural to presume that that cash will be utilized for repayment of the borrowings that we made for buying the asset in the spot market, and that is the reason that we use risk free asset as a benchmark for the pricing of forward contracts. Then we discuss the pricing of forward contracts when we have dollar returns, that is returns in terms of amounts of currency, returns in terms of money, because in that case the mere fact of carrying of the asset which we purchase from the spot market results in a realization of certain amount of cash, as a result of which the amount that we need to borrow to start with to buy the asset comes down by the present value of that amount. In other words, the amount that we are going to receive or that we perceive that we will receive during the life of the forward contract by holding the asset that we acquired in the spot market can be used to repay a part of the loan proceeds that we borrow for buying the asset in the spot market. As a result of it, the effective cost of the asset when we purchase the asset from the spot market comes down to S naught minus D naught, where D naught is the present value of the dividends that you receive during the life of the forward contract by holding the underlying asset during that period. Then we also discuss the issue of pricing of the forward contract, when instead of a dollar amount, instead of a rupee amount or a cash amount, we have a return on the asset that we acquired in the spot market. In that case, when we need 1 unit of asset for delivery under the forward contract, the short position under the forward contract, we actually need to acquire less than that 1 unit by a factor of e to the power minus q t, the present value of that. For example, if we need $1 to fulfill our short obligation under the forward contract for selling $1, then we do not need to buy $1 in the spot market. We need to buy somewhat less than $1, because that amount, when invested in a dollar deposit, will give me $1 on maturity of the forward contract, as a result of which again the cost in the spot market comes down. Let us look at the other side of things. We have talked about income being generated. We have talked about income being generated during the life of the forward contract by holding the spot asset. By holding the asset, either you have a dollar return or you have a yield in terms of percentages. What happens if instead of getting a return, you have to incur a carrying cost for holding that asset? For example, let us take the case of wheat. You buy wheat as the underlying commodity in the spot market, but to store meat, for example, to be delivered under a forward contract of 6 months, you have to keep it in a godown, for which you have to pay a certain amount of rent. Similarly, if the underlying is gold, you would like to get it insured and pay an upfront premium for the insurance. So, certain assets, when you buy the asset in the spot market and hold them for delivery against your short forward position, they entail the incurrence of a certain expenditure. The treatment is absolutely parallel to what we did in the case of income. The only difference would be that where we are taking the dividend during the life of the forward contract as an inflow, this would be an expenditure, and hence it would be an outflow, and therefore, the present value of these carrying costs will be added to the spot price instead of being deducted. In the case of dividend, we deduct the present value of dividend S naught minus D naught. In this case, it would be S naught plus U naught. As you can see on the slide presentation, F naught is equal to S naught plus U naught. Instead of S naught minus D naught, we now have a factor of S naught plus U naught, where U naught is the present value of all carrying cost that is associated with holding the asset that you acquired in the spot market for delivery against the short forward position during the tenure of the forward contract. And similar is the situation where, for example, there is a loss. Let us take the case of a formulation which evaporates at a constant rate, and thereby we are incurring weight loss by holding the asset in our godown. And that loss is given as a percentage. It is proportional to the holding at any point in time. In that case, instead of r minus q being in the exponential, we shall have r plus q, where q is now the rate of loss instead of the rate of interest or the rate of return or the rate of yield. The other things are absolutely parallel. The process of no arbitrage is absolutely similar. Let us now go back to revisit the concept of arbitrage. I want to take this up in greater detail, because arbitrage forms the cornerstone of the pricing theory in modern finance. It is the fundamental, no arbitrage constitutes the fundamental postulate on the basis of which literally all pricing is done in modern finance. The point is, what we do is we try to construct two portfolios. The two portfolios have identical payoffs, identical risk return characteristics, and then because we know the price of one portfolio, we argue that because the payoffs are same, the risk return profile is the same, therefore, the cost of the portfolios must also be the same. This is fundamentally the principle of arbitrage, but we need to look at it a bit more closely. If you look at the slide here, you got let us look at the first portfolio, portfolio 1. We have got two assets, asset A and asset B. Now, I have taken the very simplest case where we can have just the two states of nature at the maturity of the, for example, let us take the contract. Let us say the price of the underlying can be less than a predetermined value k, or the price of the underlying can be greater than a predetermined value k. These are just the two possible situations that we are looking at. K is dividing the spectrum, the entire spectrum of prices of the underlying asset into two parts. One is, and we are looking at ST less than K, that is the spot price or the stock price or the price of the underlying asset being less than K, and we are looking at the underlying price being greater than K. So, in the case of asset A, we get a payoff of 90 units, whatever that unit of money is. We get the payoff of 90 units if ST is less than K, and we get a payoff of 100 units if ST is greater than K. There is another asset available in the market which has a payoff of 100 units if ST is less than K, and 90 units if ST is less than K, is greater than K. Now, the question obviously is, can we say that asset A is superior to asset B or vice versa? Can we compare these two assets? Prima facie, we just cannot do it. Although the total payoff of both the assets is 190, which is equal, but in spite of that, we cannot say that asset A is better than B or asset B is better than A, because the payoffs under different states of nature is different. In the first case, ST less than K gives you a payoff of 90. In the second case, ST less than K gives you a payoff of 100, whereas in the other case we have a different pattern. So, if this is the situation, we have got two assets, we cannot do arbitrage as such. That is the fundamental point. Arbitrage cannot be done as such between these two assets A and B, because we cannot prima facie say that A is superior to B or B is superior to A. But there is one interesting feature here. Suppose we add 10 units of money to asset A at the point of payoff, then the payoff of asset A becomes 100 and 110. And in that situation, in other words, the asset A plus 10 units of money, asset A plus 10 units of money, plus 10 units of money, 10 money, this will give me in that case, we find that asset A becomes superior to asset B, because if ST is less than K, both the assets will give me 100 units of money, and if ST is greater than K, A gives me 110, B gives me 90. Therefore, now we can argue that the price of A plus the present value of 10 units, price of A plus the present value of 10 units of money should be greater than the price of B. Why? Because if I add the 10 units of money in both situations, that is the risk free rate, risk free 10 units of money, then I end up with a payoff asset A having a superior payoff on maturity compared to asset B, and therefore, the price of asset A should be more than price of asset B. So, price of, in other words, the equation that I get is P A plus the present value of 10 units of money is equal to or is greater than P A plus 10 units of money is greater than P B. P A plus the present value of 10 units of money is greater than P B, and that condition we can arrive at by invoking the principle of arbitrage. Now, look at the second situation. The second situation is even more surprising. Asset C is giving me a payoff of 100 units if ST is greater than K, but it is giving me a payoff of 90 units if asset D is giving me a payoff of 90 units if ST is greater than K and 90 units if ST is less than K. Can we say that one asset is superior to the other? Although asset D has a total payoff of 180 units, asset C has a payoff of only 100 units. Can we say that asset D is superior to asset C? Prima facie, again we cannot say that. Why? Because this difference in 10 units, what does it mean? It may so happen that K could be a very small value. If K could be a very small value, then the 90 units that we are talking about could be confined to a very small interval of price in terms of the underlying asset, and ST greater than K could be a much larger value, much larger price range, right. Therefore, the probability of the stock lying in the larger price range could probably be more. Again, we have to depend on probability distribution and so on, but just for the sake of exposition, that would mean what? That would mean that this 100 is more valuable to me in more situations than this 90 which is available in asset D. Therefore, probably I may think of paying more for asset C. So, the issue here is arbitrage should only be invoked when we have a clear cut demarcation between the profiles, the pair profiles of the two assets. Let me be more precise. Let us come back to, let us look at this situation now, asset X and asset Y. Now, here what is happening is ST is less than K, both payoffs are same. But in the case of ST is greater than K, the asset Y has a clear cut advantage over asset X and their prices are same. So, it is very obvious here that asset Y is superior to asset A, asset X, and therefore, in this situation arbitrage will definitely take place. So, these are some examples that I have presented. Portfolio 4 is also similar. In this case, the payoffs are 110 if ST is greater than K. Again, the payoffs here are same. Payoffs, the total payoffs in both cases are the same. The prices are also the same, but the pattern is different. Again, it is not necessary that arbitrage will take place here. The only portfolio where clear cut arbitrage is possible is portfolio 3, where X is clearly dominated by asset Y. Let us look at this diagram. Whenever we talk about analysis in finance, it is very convenient to do the analysis in 2-dimensional space with risk return space, it is called. Normally we have risk along the x axis and return along the y axis. In this diagram, let us look at assets A and B. Asset A has a return of R A, asset B has a return of R B, and it is very clear that the risk of both the assets is the same. In this situation, when you are defining the asset by only two characteristics, risk and return, and one of the characteristics is identical, if the other characteristic varies, it can be traded on and you can make money out of it. This is what is called arbitrage. But the issue is, if the markets are efficient, this arbitrage opportunity is a very short term opportunity, and gradually the process that is outlined here will take place. People will start investing in A, people will disinvest in B, the prices of A will go up, the prices of B will go down, as a result of which the returns on A will go down, the returns on B will go up, and in equilibrium these two will again tend to converge. The same could be the situation between C and D. Gradually, because they have the same return for different levels of risk. Again, we can play between these two assets, arbitrage can take place between these two assets, and because C is giving you the same return with the lower level of risk, it is more advantageous for the investor to invest in C, and as a result of it, this process will again take place. So, there are some fundamental issues in arbitrage. A set of transactions would be classified as arbitrage if either the risk remains the same or the return remains the same, as I explained just now. If both risk and return change, for example, if the question arises, can there be arbitrage between A and C, then it becomes a difficult question to answer, because then it involves a trade off between risk and return. The asset C has a certain level of risk, asset A has a certain level of risk, asset C has a certain level of return, A has a certain level of return. Now, what would be the equivalent return that an investor would expect if asset C had the same level of risk as A? This is the big question, and this is a question which cannot be answered straight away, and as a result, in these situations arbitrage becomes a complex phenomenon, because a trade off between risk and return is envisaged. Now, another very important aspect of arbitrage is, you see, if somebody is going to take implement arbitrage, it is his own money that he is going to use for doing arbitrage, and as a result of it, there is no restriction as such on the various methods or various steps or various levels at which he can do arbitrage. For example, let us say you start with Indian rupees, you convert them spot to US dollars, invest them for 3 months in US dollars, then again take a forward contract for 3 months by converting them into GB pounds, and then again come back with via present value back to Indian rupees. So, you can have a number, you can have n number. See, you can even simply play the spot market, convert rupees to dollars, dollars to Canadian dollars, Canadian dollars to pounds, and then pounds back to rupees, if you can make a profit out of this. You can play the spot and forward markets like we have just talked about. So, the various approaches to arbitrage are innumerable, but the only issue is that as the number of steps, as the number of transactions in the arbitrage cycle increases, because of market frictions at every level, the chance of profit arising out of the entire cycle diminishes, because market frictions are going to eat into that arbitrage profit. More transaction costs, more brokers commission, bid ask spreads, borrowing lending spreads, there are so many market frictions in real life, in practice, and all these things would aggregate in eating away the arbitrage profit as the number of steps, as the number of transactions in the arbitrage cycle increases. But theoretically, hypothetically, there is no restriction to that. You just have to identify an arbitrage opportunity and take advantage of that. We have talked about pricing of a forward contract. Let us see what happens. Let us see what happens if the condition of no arbitrage is violated. For example, let us start with a situation where this condition holds, that is, the price in the forward market is higher than the theoretical, the actual price in the forward market is higher than the theoretical price or the theoretical forward price, that is f 0 for maturity at t is greater than s naught exponential r. What would be the process? Obviously, because this equality is being violated, therefore, there will be arbitrage possibilities. The question is, how can one take up this or take advantage of this arbitrage situation? Now, the first thing here is, since f is greater than the theoretical price, logic says that you sell at F and you buy at S. In other words, you buy the asset in the spot market and take a short position in the forward market. So, what would be the various steps? You start with borrowing an amount of S naught and at the same time take a short forward position for 1 unit or whatever the number investment you want to make in the desired asset. With the amount borrowed, you acquire the asset in the spot market. So, you have the asset now with you, you have a short forward position with you. You carry the asset, hold the asset until the maturity of the forward contract and deliver the asset against the forward contract, receive the amount of cash F naught. So, now you have the cash F naught and at the same time your borrowing has increased to S naught plus interest thereon, that is e to the power R t. So, the net cash that you have is F naught minus S naught e to the power R t, and because of this condition that we have F naught is greater than S naught e to the power R t, this amount will turn out to be positive. In other words, by this arbitrage cycle you will have made a profit. Now, we talk about the converse situation, the other way around. When the forward price, the actual forward price is lower and the theoretical forward price is higher. Now, again because the actual forward price is lower, you will buy in the forward market, that means you will take a long position in the forward contract and you will sell in the spot market. So, what will you do? You will borrow the asset and sell it in the spot market to realize an amount of money S naught. This is called short selling. Borrow the asset and sell it in the spot market. So, you get a amount of cash S naught which you invest at the risk free rate R. Now, on maturity of the forward contract, you will receive the asset and you can replenish the asset to the original owner of the asset. So, that transaction is completed. You will have to pay F naught. So, that cash outflow is F naught and your cash investment S naught that you made at t equal to 0 by selling the asset that you borrowed has now incidentally become S naught e to the power R t, S naught e to the power R t. So, your net cash flow is S naught e to the power R t minus F naught, and because of this condition this figure becomes positive and again you make an arbitrage profit. This process is called reverse cash and carry arbitrage. The previous process where you were holding the asset from the spot, buying the asset from the spot market, holding it and then giving it against the forward position, that was called cash and carry arbitrage. This is called reverse cash and carry arbitrage. So, in the cash and carry arbitrage situation, the forward price is higher than the theoretical forward price. In the reverse cash and carry arbitrage, the forward price, actual forward price is less than the theoretical forward price. There is an example here, a 1 year long forward contract on a non dividend paying stock is entered into when the stock price is 40 and the risk free rate is 10% per annum with continuous compounding. At the time the forward contract is 46, is there any possibility of arbitrage? Let us look at the solution. S naught is given as 40, the interest rate is 10% and the tenure of the forward contract is 1 year. So, the theoretical forward price, which we call the no arbitrage forward price, is equal to 44.21. Against that, the actual forward price that is prevailing in the among the market is 46. Therefore, there is a clear cut arbitrage opportunity. Because the forward price is higher and the theoretical forward price is lower, you will sell in the forward market, you will buy in the stock market. In other words, what you will do is cash and carry arbitrage. A slightly more complex question. Today is April 1, 2018. A stock is expected to pay a dividend of 2.10 per share in 2 months from now, and again in 5 months from now. So, there will be 2 dividend payments, one dividend payment at the end of 2 months from now and the second dividend payment at the end of 5 months from now. The stock price as of today is 50 and the interest rate is, the risk free interest rate is 24% per annum with continuous compounding. Calculate the no arbitrage forward price. What is the formula for the no arbitrage forward price? It is F naught is equal to S naught minus D naught e to the power R T. What is D naught? D naught is the present value of all dividends that you receive during the life of the forward contract, during the entire life of the forward contract. So, S naught in our given problem is 50, stock price is 50, the interest rate is 20, R is 24%, life of the contract is 6 months and there are 2 dividend payments at the end of the second month and at the end of the 5th month. The interest rate, the annual interest rate is 24%, therefore, the 2 month interest rate is 4% and the 5 month interest rate is 10%. Correspondingly, the present value factors are 0. These are the present value factors 0.9608 and 0.9048 are the present value factors PVIFs, and this is the present value of dividend 2.0177 and 1.9002. The aggregate present value of dividends, both the dividends together, the aggregate present value is this amount. Therefore, S naught minus D naught works out to this, and the future value of this, which is the value of the forward contract, is 51.9575. Let me put a plus here because. So, this question, now the important thing here is we are having 2 different dividend payments and each has to be discounted to be brought to t equal to 0, and this D naught is the aggregate present value of all the dividend payments during the life of the forward contract. Whatever dividend payments are there during the forward contract, the present value of that. Now, so far we have been talking about investment assets. You will recall that when we started talking about pricing of forward contracts, we had a bifurcation of assets into investment assets and consumption assets. Investment assets were those assets that were held for the purpose of investment, like gold, silver, stocks, currencies and so on. Consumption assets were those assets which were held for consumption, like copper, coal, wheat, barley, etc., livestock, etc. At that point, I said that we will talk about the significance of this bifurcation at a later point in time. It is here that we now talk about it. Now, what happens is, how does reverse arbitrage take place? In order to facilitate this arbitrage, what would be the process? The process would be you acquire the asset, you sell it in the spot market and you buy the asset in the forward market and replenish it to the person from whom you bought the asset or borrowed the asset. Or if somebody is owning the asset, he can sell the asset in the spot market and thereafter buy the asset in the forward market. You own the asset, you sell the asset because you feel that as of now, by selling the asset you can make a greater profit when buying the asset in the forward market. In other words, the important thing here is, the thing to understand is that between today and the maturity of the forward contract, between this period you are dispossessed of the asset, you do not have ownership, possession of the asset. You have sold the asset, invested the proceeds, cash, and you recover the asset only at the maturity of the forward contract. So, how is this classification of consumption assets and investment assets relevant in the present case? That is what we will take up.